to make the best of the lesson. Harriet, hello. Chris, Pagnia, hello everyone. Okay, I hope I'm already recording, just in case someone needs to watch the recording later. And one little note, next week, we still have one more session, yeah? Because next week, all of you are missing just one paper. Depending on the exam board, some of you are going to not have pure at all. Some of you won't have mechanics, and some of you won't have statistics. So what I'm going to do is a longer session, 1 hour and a half, and I will do half an hour pure, half an hour mechanics, half an hour statistics. So all of you can join 1 hour, but then you can combine whatever you are missing, yeah? I will tell you when I send the email, I will tell you I'm doing from 2 to 2:30 pure, 2:30 to 3 apply mechanics, and 3:30 or 3 to 3:30 statistics, or wherever I'm going to organize them. But don't worry, because still you will have 1 hour. You just have to combine what you need. So you can book this in my website. I will send later the link in the email if you need. And you have on Google, on my website, still the recording of the previous master classes available to buy. Yeah, so you can get the master class that sometimes is 2 hours, together with a booklet with questions, and you have their functions, you have forces and motion, you have hypothesis testing, you have trigonometry. So there are lots of things that can be useful. Yeah. Okay, so Excel and AQA, you didn't have distribution rule. You remember probably how to do these questions. You have the formula in the formula booklet. Sometimes they're going to tell you the strips that you need or the ordinates that you need. In this case, it's even easier because they give you the values that you're going to use for the y. So the formula is in the formula booklet. Remember, is so the area or the integral is going to be approximated by h divided by 2. And then you have the coordinates. The first one and the last one are just alone. And then you have 2 multiplied by all of the middle ones. Yeah. So h is the width of the interval. So if you have already the numbers, it's very easy to see the width must be the same. Yeah. So the width of the intervals in this case is 1.5. So you are doing 1.5 divided by 2. And then, so this is going to be 1.5. Actually, we haven't even read the question. Let me show you. So we are trying to integrate this function. This, they say use the trapezium rule. It's just because I read the question before, but you haven't. We are using the trapezium rule for this integral, sorry. So is 1.5, which is the width of the interval, divided by 2, and then first ordinate and the last one, so 1.63 plus 2.63 are on its own, and then 2 on their own, 2 plus 2.26 plus 2.46. Yeah, and calculator. I would recommend you to not skip these steps. So don't go, I know it's very tempting to just go with the values into the calculator, but if you make a mistake for whatever reason, you will lose both marks, the answer ones and the working out ones. Yeah, so I would recommend you to not skip this. I'm going to give you the answer instead of you waiting for me. It's 13.3 or 514. Yeah, so 13.3. That's the first one. I chose this question just to remind you how, because you are very likely to have a trapezium rule question. It can be very simple like this one, a bit more complicated. They might or not give you the table. These are the ordinates. If you have 1, 2, 3, 4, 5 ordinates, you're going to have 4 intervals. Yeah, so the intervals are the strips. So you're going to have always 1 strip less than ordinates. Then I wanted to show you this one because this is quite a curious one and it's not difficult. So using this information, we have to find these couple of integrals. Yeah. So how do you think we can do this one? So we have the same limits. we have the same log, but we have a power there. What I'm going to do to find the integral very quickly. Anyone? Well, you're going to be very quiet the whole lesson. Leslie, tell me.
Can we multiply 13.3 times 10? Using like rules of the logs, you put it in the front.
Exactly. So this, using the properties of the logs, is the same that 10 integral between 3 and 9 log 2x dx, and we know that is the 13.3 that we got before. Yeah, so it's going to be 10 times 13.3 without calculating anything else. Yeah, using the properties of the logs. What about this one? It's not going to be very dissimilar. So you have to think that what you know is log of 2x, how that is connected with 18x. So 18 is 9 times 2x. And then again, we are going to use the properties of the logs. Yeah, so I hope you're all seeing that. We have between 3 and 9, log of 9 times 2x dx. We separate using the properties of the logs. This is base 3. So I have integral of log 9 to the base 3 plus log 2x to the base 3. So I can separate, this one is 2. You can do with the calculator or just thinking that 3 squared is 9. So really I'm integrating 2. Still I haven't integrated, yeah? So don't skip the integration. 2 plus log 2x. Integral of 2 is 2x between 3 and 9, and then I have the integral between 3 and 6 of log 2x. That is the one that I did with the trapezium rule, yeah? Sorry, I'm squeezing things. So this is going to be equal to, I substitute the 9, so 2 times 9, 18, minus I substitute the 3, 6, and then plus the 13.3, yeah? So this bit here is this bit here. So we have 12 plus 13, 25.5. You see, it was just a different question where you had to use the properties of the logs. So I know some of you had the typical exponential modeling. Edexcel students. AQA, you didn't have a massive question like that with lots of marks, but I think all of you should expect more logarithms and exponential. So maybe Edexcel, one of those nonlinear models, yeah, the ones that you code into log and log something else. I doubt it because the other question was quite long already, but definitely show some knowledge of logs and exponentials somewhere. Yeah, maybe integrating, differentiating, something. You expect more exponentials. Yeah. Is clear? Do you have any question? No? More. Binomial expansion. Again, something that is very likely that you're going to have. Remember, you have year 12 questions, you have a formula when n is a real number, is a natural number, and in the year 13 questions, you move into real exponents that at the end are going to be powers of a half or negative powers. Yeah, this is a very typical one, but I wanted to show you for a couple of things, yeah, for the approximation and for the overestimate or underestimate. So it has a couple of things that I would like you to revise. Remember the formula is in the formula booklet. I should have put it there for you to use it. Remember, you have the 1 for natural exponents, so the year 12 1, and the 1 for real exponents. So for year 13 questions, you need to use this one. And I'm going to copy it here so you can use it. Sorry. I want to leave there. So I'm going to leave it here so you can use it. Remember that for the year 12 questions, it matters what we have here. So this is a 1 and must be a 1. So if I have something different, like here that I have a 4, I have to factorize. Yeah, so I have to prepare my question before starting even to. So this is a formula before starting the expansion. Yeah, so I have to expand in ascending power of x first 4 terms. So I have 4 minus 9x to the power of a half. That's why I know that it's a GIA13 question. So I'm going to factorize the 4 outside. If I factorize the 4 outside, I have to make it to the power. Yeah, so these 4 can go outside, but I have to do the square root. And then it's 1 minus 9x over 4 to the power of a half. And now I can use my expansion. So my x is all these together with the minus and the coefficient and all that. That's going to be my x in my formula. And then n is 1/2. Yeah, so I just go to the formula and substitute without forgetting that I have a 4 to the power of a half, which is 2, at the front. So I will write it at the front so you don't forget, and then expand. Yeah. So if we go to the formula, you have 1 plus nx. So 1 plus n, which is a half, x, which is minus 9x over 4. I wouldn't skip steps because it's very easy to miss one sign just because you are skipping steps. Yeah, that's my experience. Then I have n minus 1. So 1/2, n minus 1 is minus a half, divided by 2 factorial, and then my x, which is all this thing squared, and I need 4 terms, so 1 more, and then I have 1/2, 1/2 minus 1 is minus a half, 1/2 minus 2 is minus 3/2, all divided by 3 factorial, and by my x to the power of 3. And again, I would then skip steps, just in case you make a mistake later, you still get all the marks for the working out, yeah? Now, before expanding the bracket, I'm going to find the coefficients, yeah? Calculator, slowly, take it easy, so we don't make mistakes. I wouldn't include the signs because the signs are very easy to think. Oh, and if you include the signs in the calculator, you will need to write brackets, and it's a bit annoying. So I will think the signs. So we have 1 minus, in this case is 9/8 of x. Then the next one, this becomes positive with a minus becomes negative. So I have minus. And then in the calculator, you can do that very quickly. And I get 81 over 128 x squared. And then the last one is going to be positive, and I have sorry, someone is joining. The last one is going to be 729 over 1024. Yeah? Did you get the same? These coefficients? Okay, Luna, thank you, and the thumbs up. Thank you, thank you. So now the last thing we do is multiply by 2. So we have 2 minus 9 quarters x minus 81 64 x squared plus 729 over 512 x cubed. I will have more terms, but I have to find only the brackets, the first 4. Yeah, that's what they ask you in the first part. Then they don't tell us, but when we do this expansion, remember this is only valid for some values of x. Usually they ask you, yeah, that specify the values for where the expansion is valid. I think it takes nothing to add that, even if they don't ask you, because I've seen some mark schemes where they say that you have to specify when the expansion is valid. If not, it's not completed. So just in case, I would say when the expansion is valid. Your x, remember, is on this. So that absolute value of that thing, your x, must be smaller than 1. Yeah? And remember, this is going to be absolute value of x smaller than 4 over 9. I think it costs 20 seconds, and then you're sure that you are giving the complete answer. Yeah, the expansion with where is valid. Yeah, so valid here. Then they say a student uses this expansion with x 1 over 9 to find an approximation from root 3. Using the answer to part A and without doing any calculations, state whether the approximation will be an overestimate or an underestimate. Do you all remember how we are going to do? Imagine they ask us to do the approximation. Do you remember how we are going to do the approximation? So if they give us the value, they make us a huge favor, yeah? Because in the just 12 questions, it's very easy to find the x that you're going to use to substitute, yeah? But in the just 13 questions, not always. So if they give us the value, in this case is x is 1/9, we are going to approximate, we are going to substitute the x/9 here and see what we get. In this case, when I substitute 1/9, I have 4 minus 1, which is 3. So it's precisely √3. So if I substitute my 1/9 in my binomial expansion, I will be approximating precisely √3. But in some questions, when you substitute this here, you don't get √3. You, for example, get 2√3 or √3 divided by 3. So when you use your binomial, substituting the 1/9, you are still getting an approximation of 2√3, sorry, which means the number that you get still has to be divided by 2, yeah? So be careful because approximations in JAR13 are not always immediate. Yeah, so you have to think sometimes, how do you get the number that you are approximating? In this case, it's not the case, and they don't even ask you that. What are they asking you? They're asking you if it's going to be an overestimate or an underestimate. I remind you that we are approximating because we are just using the first 4 terms. Yeah, so this will carry on, and we are not using the rest of the terms. So do you think it's going to be an overestimate or an underestimate? And actually, this one is minus as well, no? This one is minus. I got this sign wrong. So they are all minus from here, sorry. What do you think? Can you type in the chat O for overestimate or U for underestimate, please? What do you think? So if I use that approximation for √3, do you think it's over or under? Yes, excellent. I would ask you why, but none of you are going to tell me. So I am missing here some terms. You look at the terms and they are all negative, yeah? If they are all negative, that means that if I add more terms, I will keep subtracting small things. And smaller and smaller and smaller, because 1/9 is very small. And when it goes to a power, even smaller. But that means if I stop here, I'm going to subtract other numbers. So this is going to be an overestimate, yeah? If I keep adding terms, at the end, I will have the actual value, yeah? So it's an overestimate, and that's the reason. It's because all the terms are negative, so I will subtract some other numbers, yeah? I noticed that there was a minus instead of a plus, precisely for that, because these questions, when they ask you if it's an overestimate or an underestimate, they only do that when these are all positive or all negative. Because if they are alternating, at the end, they could be compensating each other, so it's very hard to know if it's an overestimate or an underestimate. It could be either, really, yeah? So if they ask you, it's because they are all minuses and then you are missing negative bits, or they are all positive and then you are missing adding more things, yeah? Is this clear? Do you remember well how to do this binomial expansion? And how would you do if you have to really approximate that? Remember, you will substitute the 1/9 in your expansion, yeah? Any question? No? More? Okay. More questions. This is parametric equation question, yeah? And I definitely expect more integration and more differentiation. You didn't have enough. It's usually it's in all your papers, yeah? So figure 6 shows a sketch of the curve with these parametric equations, yeah? So it's this one here. And the line L is normal to C at point where T is 5/4. So if you have the tangent here, the normal is just perpendicular to the tangent, yeah? And that's what the equation is. Using parametric differentiations, show that an equation for that line is this one here. Remember to find the normal. We are going to find the gradient of the tangent, and then negative reciprocal is the gradient of the normal. So what do we really need? We need the point, and we need the gradient. To find the point, I have the parameter. And I have the equations that give me the x and the y. So if I substitute the parameter, I will have the coordinates of the point. And if I differentiate, and again, I substitute the parameter, I will have the gradient. Yeah, and that's all I need. So let's start finding the point. I know maybe you are already differentiating. I'm going to start finding the point. So point P, the x is 2 tan pi quarters plus 1. Yeah, so 2 tan pi quarters plus 1. Calculator in radians. No, what I'm doing, 10 pi quarters is 1 times 2 is 3. So this is 3, and the y is going to be 2 sec squared plus 3. So 2 sec squared plus 3. Most calculators don't have the sec. So remember, sec is the reciprocal of cos. So we are doing this instead. Yeah. So I get 7. Yeah. So point P is 3, 7. Then the gradient. To find the gradient, we are going to do dy by dx. Remember, if I have parametrics, I'm going to do dy by the theta in the top and the x by the theta in the denominator. Yeah, so I'm going to derivate the y, the x, and I'm going to divide and substitute the parameter. So dy by the theta, we have derivative of tan. Derivative of tan is in your formula booklets, is sec squared. Yeah, so derivative of this is 0, and I have 2 sec squared. That's in the denominator. Please be careful, because we always find the x first. Well, it's t, not theta, no? They're calling, sorry. T. It doesn't. Leslie, tell me.
I just have a question about finding the value of y, because instead of using cos squared at the bottom, I just use tan squared plus 1.
You can, yeah.
Yeah, the thing is, it gives me 6 instead of 7, and I don't see, like, it should give me 7. I don't see why.
Have you used a bracket?
Yes, I put it like normally, the calculator, the pi over 4, it's in the bracket.
And everyone else gets 7, or maybe I got that wrong?
Because I use the cos also to check, and I get 7. So I don't understand why we don't.
So sec is 1 plus tan squared, no?
Yes.
Tan squared, tan pi quarters is 1. So this is 1 plus 1, 2 times, yeah, you get 7. This is 1 plus 1, 2.
It's because I put the
4 plus 3, 7. No?
I put the 1 outside. Or do you put it all together in the same? Oh yeah, now I see why you multiply the one by 2 as well. I see. Sorry, I just plugged it differently in the calculator. That's why. Okay,
good. But that definitely you can use that. So this is dx. Be careful of not swapping them, because we have them in different order. And then the y, I'm derivating sec squared. How do I derivate sec squared? Do you remember? It's a function squared. So I'm using the chain rule. Yeah, a function squared, the 2 goes to the front, the sec to 1, and then I derivate sec. Yeah, and the derivative of sec is sec tan. So you have it in the formula booklet. So let me show you. We use the tan, and the sec is sec tan. Yeah, so don't worry, because those are in the formula booklets. But you have to remember the chain rule. So you have a function to a power. So derivative of that, I'm going to make space. Derivative of that is, so we have, I need to copy them. So tan t plus 1, and y is 2 sec squared t plus 3. So I have 2 times 2 So these two that is here, these two from the exponent, then sec to 1 less. And then the derivative of sec is sec tan. So I'm going to square this one and tan. Yeah, if that makes sense. We can cancel the sec square and we can cancel 1, 2, and our derivative, just to make it simple, because it doesn't matter, we are going to substitute. So it doesn't matter if you don't say simplify. And that's the derivative, but we are going to substitute the parameter, yeah? So we are trying to find the gradient when t is pi quarters. So when t is pi quarters, tan pi quarters is 1 times 2 is 2. The gradient of the tangent, so the gradient of the tangent is 2. Yeah, I'm talking when t is pi quarters. So the gradient of the normal is minus a half. Yes, everyone has the same? So the equation of the normal is going to be y minus the y of the point. So y minus 7 equals minus a half, which is the gradient of the normal, x minus 3. And now we just going to check how they give us the answer. Yeah, so they make y the subject, so we can do the same. So to make y the subject, we have y equals 7 minus a half x plus 3 halves, and then we can put together the 7 and the 3 halves, yeah? So 17 halves minus 1 half x, which is precisely what we have, yeah? It's clear? So see how we have differentiated. Remember that you have a few trigonometric functions in the formula booklet. And remember, when you have a function to a power, it's going to be the chain rule. Yeah, it doesn't matter if it's sec or if it's whatever it is. A function to a power, the power to the front, the function to 1 less, the derivative of the function. Yeah. So it's the chain rule. It's like having u to the power of n, I have n, u to 1 less, and the derivative. It's just that. Show that all the points on C satisfy this equation. What are they giving me? The Cartesian equation, yeah? So they have eliminated the parameter. How can we eliminate the parameter? There are a few ways. So when you have trigonometric functions in your parametric, think about the identities. That would be my first choice. So you have an identity that connects the sec square with the tan square. So that would be, or that should be your first option. If not, and if the things become very complicated and you cannot eliminate, another option is just to go here and substitute. So if you see that it's too messy, too complicated, and they give you the final equation, there is nothing wrong with substitute the x, substitute the y, and see that left-hand side equal to the right-hand side. That's something that you always can do, yeah? But I'm going to make tan the subject, sec square the subject, and do 1 plus tan square equal to sec square, yeah? And it's going to do that. So these are my equations. That's why I copied them here, so we don't forget them. From the first one, tan t is x minus 1 divided by 2. And from the second one, sec squared t is y minus 3 divided by 2. So I'm going to do tan squared plus 1 is sec squared. Remember, you need to remember which one is the one that goes with the plus 1. If you don't remember, they are very easy to deduce. From the sine squared plus cos squared is 1, dividing by sine squared or by cos squared, yeah? But you need to remember which one is the plus 1. So I have 1 plus tan squared equals to sec squared. The sec is already squared, don't square it, yeah? You only have to square the tan squared. And now let's see how they give us the answer. Again, y the subject, and they don't expand this bracket, yeah? So that's what we are going to do. Y the subject, and we are not squaring that bracket. So we have the y minus 3, the 2 multiplying everything, so 2 plus x minus 1 squared, and I have a 4 in the denominator because it goes square, then multiply with the 2 becomes a 2, yeah? And the last thing I'm going to do is to add the 3. So I have 5 plus x minus 1 squared divided by 2. Or if you want to give the other way around, that is how they give it, is okay. Yeah. So identities, when I have I would say parametric equations and you have trigonometric functions, think about the identities to eliminate the parameter. Yeah. Then the straight line with this equation, where k is a constant, intersects C at two distinct points. Find the range of possible values of k. And it's a lot of marks, but it's much easier than what we've done. This is almost a year 12 question. So we have a straight line, and we are going to use the Cartesian equation. Yeah, it's a quadratic. It's a quadratic and a straight line, and we have to find the values of k for have two distinct points. We are going to solve simultaneous equations. It's going to be a quadratic, and we are going to use the discriminant. Yeah, so you have done that quite a lot of times. So I'm going to use another page. So my quadratic was x minus 1 squared divided by 2 plus 5, and the straight line is what? Even if you're not able to deduce this in the previous part or do this, don't skip whole questions. Yeah, if you're confused eliminating the parameter or finding this normal, you know perfectly how to do this, and it's 5 marks. So don't lose all the marks in a question because you cannot do the beginning. Yeah, sometimes the questions are quite independent. So minus a half x plus k. Yeah. Define intersections, we solve simultaneous equations. So the left-hand side, so this one is going to be equal to this one. We are going to have a quadratic, and it's going to have two solutions. So 2 points of intersection when the discriminant is positive. Yeah. So I'm going to multiply everything by 2 first and expand the bracket. Yeah, no, I multiply everything by 2, and then I reorganize. I have x squared minus x plus 11 minus 2k equal to 0. So this is going to be my c, which means the discriminant is going to be minus 1 squared minus 4ac. Yeah, did you get that? To have two real solutions, this must be positive. Yeah, it's not even quadratic. So it's 1 minus 44 plus 8k greater than 0. I don't know why it sounds like it's not correct. Do you have the same? Minus 2x plus, yeah, I think. So I have 1 minus 44 is minus 43, so 8k greater than 43. Therefore, k must be greater than 43/8. Did you get that value? That sounds like a... Yeah? Okay, amazing. I don't know why it sounded wrong. If you have to write sign notation, please remember the curly bracket, k, column, and then your answer, and you close the curly bracket. Yeah? They don't ask you, but you can give the answer definitely in this way, and you have to give the answer in this way if they say notation. Yeah. Is it clear? So when the discriminant is positive, this is going to have two solutions. So there are 2 points of intersection, and it's just... Any question? Look how complicated way of giving a quadratic equation, no? Because this is just a quadratic, and look the parametric equations. You have no clue of what they are. Okay, again, expect parametric equations, yeah, if you haven't got them. More things. Normal distribution. Yeah, again, some of you will have it next week, some of you the week after, but I doubt that you don't have a normal distribution question. This one is quite straightforward. So you have the level in grams per millimeter of a pollutant at different locations in a certain river is denoted by a random variable x and has this distribution. It's kind of a strange standard deviation. Yeah, so I have 4 zeros, 1, 2, 3, 4, after the decimal point, and then 409. Yeah, remember this is sigma square. It's very common that you have the square there, and that reminds you when you type in the calculator, you have to do the square root. Yeah, don't forget that. In the past, the value of mu has been this one, and this year the mean level of the pollutant at 50 random chosen locations was found to be this one. So this is the observed value of the mean. Yeah, and it's a hypothesis test question. Remember, you have the masterclass of hypothesis testing in my website. Yeah, you have hypothesis test with binomial, with correlation, and with normal distribution, and it's on the website. Test 5% significant level whether the mean has changed. So it's 7 marks. Even if they don't scaffold it and say, write the hypothesis, blah, blah, you have to do that. So first of all, we have to write the hypothesis. Remember, in the normal distribution, I check the mean of the normal distribution. So this one is going to be that the mean is the one that I thought it was. So this one, 0, 0, 3, 4, 0. So not the one in the sample, but the one that is the 31. And then they ask me if, or they want to check if it has changed. So if it's different than that, if it has changed. So we are not checking if it has increased or decreased, if it has changed. My significant level, because this is a two-tailed test, is going to be split in half. Yeah, be careful and always remember two-tailed. This is going to be 2.45% in each tail. Yeah, there are two ways of doing these questions, with the critical region or just comparing the observed value with the significant level. I'm going to do the shorter one, but you can use the critical region. So one thing that you need to remember is if your X is this normal distribution, then mean is distributed in a very similar way, but not exactly the same. So remember, this is going to be a mu that is 0, 0, 3, 4, and the standard deviation is the standard deviation divided by n. So I have to write the 0.1234409 divided by n, which is 50. If you don't divide this by n, you're going to get something different. Not hugely different, but enough for them to see that you didn't remember. Yeah? So you have to remember this. If the normal has this distribution, the mean of the normal has this distribution, which is just dividing by 50. And you have to remember, when you write this in the calculator, you're going to do the square root of this. So sigma is the square root of this thing. Yeah? That's what you have to type in the calculator. Yes, so what are we going to find? The probability of the mean being, we have two tails. So we have to think a bit if we are using the smaller or greater, because it could be either. Look at the value. The value is slightly below the one that we expect. So that means we are checking small values. So we are going to check small than 0, 0, 3, 2, 5. Yeah. If the observed value in the sample is greater, we will be checking greater. Yeah. This probability with this normal distribution is, so normal CD, the lower limit is going to be a very small number. Upper limit is the 0.0325. Sigma is going to be the square root of that horrendous thing there. And the mu is 0.034. So I get, and tell me if you get something different, 0.0486, something else. I'm going to compare this with half of my significant level. So this is greater than 0.025. And because it's greater, I don't have enough evidence to reject H0. It's still very likely to happen. Yeah, it's a big enough probability to happen for this to be true. Yeah, so what do I have to write? Something like this. There is not enough evidence there is not enough evidence to support that the pollutant has changed. Yeah, the level of pollutant has changed. Evidence to support that level of pollutant has changed. Something like this. Yeah. This bit, there is not enough evidence, so there is enough evidence, is something that you always have to write. And then how you phrase it, I will go back to the question and see how they are telling you exactly what you are testing. Yeah, in this case, whether the mean level of the pollutant has changed, that's what you are going to say at the end. Did you get this probability? Remember, our sigma is the square root of all this value. And really, really, really is important that you remember, because this doesn't happen when we do correlation hypothesis testing or binomial hypothesis testing, is your distribution changes. So you need to remember this 50 here at the bottom. Yeah, if not, you get something different. Is it clear? Okay. Please remember the masterclass on the website, because it's all about this. More. Let's going to do one mechanics question, because some of you have mechanics next week. This is a moments question, and I chose this one on purpose because it's a moments question. You have a rod, and this has an angle, yeah, and that's a bit unusual. So I'm going to show you what we are doing. Yeah, it's not more difficult, but most of the times, if you have something else, is going to be perpendicular. Now this adds a bit of complication, yeah, but not much more. So we have an uniform rod. So uniform, remember, is telling me that the weight is in the midpoint. So I can straight away in the midpoint draw my 5 kilograms mass times G, length 8 meters, one end resting on rough horizontal. So again, mark these type of things, rough horizontal ground. So we are going to have friction. You have to think in which direction. So I have friction here. Do you think it's pointing to the right or to the left? Can you type in the chat right or left, please? So in which direction do you think the friction is there? Right or left? Yes, perfect, exactly. Left, because if this was very slippery, this thing will go that way. And the friction goes against the direction of motion or the tendency. Yeah, so if it's not moving, you have to think, how could that move? If that is in limiting equilibrium, like all your questions, which means your friction is going to be mu normal reaction, where normal reaction is the reaction here. Yeah, so you can assume that straight away, because it's in limiting equilibrium. And then we have this tension here, no? That is T. They give us the tan of the angle, so they say tan alpha is 3/4, which means we know sine and cos. And distance, we know this distance, angle between the, and this one is beta, which is different, and we know coefficient of friction between the rod and the ground is 2/3. So this coefficient of friction is 2/3. So I'm going to write it here, 2/3. And the vertical component of the force is R. So they are calling it R, like I was, and that's it. We have defined the value of R here, and it's 6 marks. So expect some working out. This is a moments question, obviously. If we try to solve forces to find this R, we have vertically, we have this force and this force, but this one we don't know the value and we don't know the angle, which means we are going to have too many unknowns. So we have to take moments. If we take moments about here, we won't have the tension in the equation. Yeah, and we don't have to find it. We don't have to find it even in the second part. They are only asking us beta. So I would say it's the most convenient point to take moment. Yeah. Remember deciding in which direction the moments are acting. So this force is producing a clockwise moment. So this one is going to be clockwise. This force about C is producing anti-clockwise moment. And this force about C is again clockwise. So we have two clockwise two clockwise, that because this is in equilibrium is going to be equal to the only anti-clockwise that I have. So how do I write an equation? So moments about C is going to be 0. And I always recommend you to write where are you taking moments about, because sometimes it's difficult to follow. If you have a distance run or something, it's almost impossible to know what point you are taking moments about. So please try this, and it will help the person that is marking. Yeah, this one. Think carefully about the perpendicular distance. So remember, the moment is the force, which is 5g, multiplied by the perpendicular distance from the point to the line of the force. The line of the force is this one. So what perpendicular distance I'm talking about? I'm talking about this perpendicular distance from the point to the line of the force. Yes, that's my perpendicular distance. This angle here is alpha, yeah, the alternate angle. So this angle here is alpha. So you really need to look at this right angle triangle. The hypotenuse, if this is the midpoint, this is 4 and this is 1. So this is 3. Yeah, this bit is 3. So that means the perpendicular distance is 3 cos alpha because it's adjacent. Yeah, so 3 cos alpha. So that's the distance that I have there. 3 cos alpha. Then the other clockwise is the friction one. I have to do the same with the distances. So my force is 2/3 r, but then I have to decide the perpendicular distance from the point to the line of the force. So this is the line of the force. So my perpendicular distance is this one here, this distance. So again, you look at this triangle here. The hypotenuse is 7. Yeah, so this length here is 7 because the whole bar is 8 and this bit is 1. So this is 7 and this is the opposite. So it's 7 sine alpha. That's the perpendicular distance times 7 sine alpha. And that's going to be equal to the anti-clockwise moment, that is this one. Line of the force, again, is this one. So quite similar to the first one that we did, yeah? And now the perpendicular distance from C, here perpendicular. So now we are looking at this big triangle. We say this is 7, and this is the adjacent. So it's cos again. So 7 cos. This bit is 7 cos, yeah? So I have R times 7 cos alpha. Does the equation make sense and the perpendicular distances? Because that's the bit that is confusing. Then from now on, it's nothing. Are the distances clear? Remember, you're doing distance. You have to draw a perpendicular from the point to the line of the force, which most of the time means that you have to stretch a bit the line of the force, yeah? And now we can, using tan, find sine and cos, or I would just divide everything by cos. So we work even less, yeah? So this cancel, and this is sine divided by cos, which is 3/4. You not always can do that in the questions, but when you can, it's better. So I have 15g plus these 3 with these 3 are gone, and this 4 with these 2 becomes 2. So 7r divided by 2, if I'm not mistaken, is equal to 7r, no? What do we need? R. So 7r minus 7/2. What I'm doing? I'm on the right, no? So on the right, I have 7r halves equal to 15g. So R is going to be 30/7g newtons. Yeah, you can leave it like this, or you can multiply the g and have the actual number. But let me check. Let me get. Yeah, so you can leave the 30/7g or 42. It's up to you if you multiply or not. It's clear how we have written the equation, because once you write the equation, it's just very quickly to solve. Yes, everyone? Then find the size of angle B. Now we have this R. I'm going to clean a bit the drawing so we don't have so many stuff here. We are trying to find angle beta. Angle beta. So I will have, so if you consider the components of the tension in both vertical and horizontal, because the other forces are already vertical and horizontal, is going to help us. Yeah. There are a few ways of doing this question. I would split this beta in two angles because this angle is going to help me to find the components and this angle is alpha anyway, yeah, because they are alternate angles, yeah. So this beta, I would split it in alpha because they are alternate angles and, for example, theta, yeah, and then beta is going to be alpha plus theta. We know alpha because we know the tan and we just need to find theta and then add them. That's what I would do, but you can work with whole beta if you prefer, yeah. Then the components of T are going to be, the horizontal is going to be T cos theta because it's adjacent, yeah? And the vertical is going to be T sine theta. T sine theta, right? And now is when we can try to use resolving forces because it's going to be easier than take moments again. And most of the questions you have to take moments for sure, but it could be that some other bits of the questions you just can resolve forces. And that's the case. So T sine theta up plus this one that I just found, so I know the value of this one is going to be equal to 5G. So I know that this one up plus this one up is going to be equal to this one down. I have two unknowns. I have T and theta, which means I have to do something else. What the something else can be? The same by horizontally. Yeah, so this one to the right is going to be equal to this one to the left. And then we will have it. Two equations, two unknowns. Let's going to do that. So resolving vertically, I have T sine theta pointing up plus R pointing up is the weight that was 5G pointing down. Yeah. And resolving horizontally, I have that T cos theta to the right is going to be equal to the friction to the left that was 2/3 of R. Yeah. And we know R, we just found it, and we need the angle, but we don't need T. So R is not an unknown. I can't even write what it was, so we don't forget that we know it. So it's 30/7G, no? 30/7G. So, sorry. 30/7G times 30/7G. We want theta. When you have a situation like this one, so simultaneous equations and you have sine and cos, again, there are a few ways of solving them. So if you want T, you want to eliminate theta, so you can use sine square plus cos square equals to 1, and then you eliminate the theta. But in this case, we want theta. So what I would do is to make this the subject, and then divide sine by cos. So we can cancel the T and have tan. That would be probably the best. Yeah. So my first equation will look like T sine theta is 5G minus 37 5G, no? Which is 5/7 G. I'm just putting these two together. Yeah. And then the other one is going to be T cos theta equal to 60/21G. And now we divide the one with the sine by the one with the cos. So T sine theta divided by T cos theta is 5/7G over 60/21G. Yeah. This cancel, and we have the tan theta is that 5/7 divided by 60/21. And from here, we can get theta. In mechanics, we always work with degrees. If you, for whatever reason, give your answer in radians, they can't really tell you anything, but you have to specify, yeah? So I'm going to work in degrees, and I'm going to do 10 minus 1 of 5/7 divided by 60 over, well, I could have simplified that, I didn't. 14.036, no? 14.036 degrees, and I know alpha. Yeah, I have to add alpha because I'm looking all beta, and beta was alpha plus theta. So tan alpha is 3/4. Tan alpha is 3/4. That means that alpha is 36.869. So that means that beta is alpha plus theta. As I said, you can work with beta only, but I think this is easier. And I get 50.9. 50.9 degrees to 3 significant figures. Is it clear? You get the same. Thank you. Everyone, is this moment's question clear? Yeah, so think that moments questions are going to be always a combination of moments, but you can use the forces as well. Forces are easier because you are not working out the distances, but you cannot get away doing one of these questions only with forces. Yeah, it's always going to be taking moments somewhere. And when you take moments about any point, because the thing is in equilibrium, the resultant moment is going to be 0. So all the clockwise moment is going to be equal to all the anti-clockwise moment. And that's how you do the equations. The bit difficult sometimes is the angles. Yeah. When you have those horizontal questions with two supports, where all the forces are up and down, the moments are very easy because the distances are just horizontal distances. But in these questions, you are going to always use the trigonometry. Okay, so that's it. I have, I think, 1 or 2 more questions just because I always have extra questions just in case. You can maybe try them. And if you have any question, I will do them next week anyway. And as I say, next week, because some of you won't have pure anymore, some of you won't have mechanics, and some of you won't have statistics, I will do 1 hour and a half. So I will do half an hour in each thing. And you can combine and get only the pure and mechanics, or the pure and statistics, or the mechanics and statistics, depending on your example. Yeah. That's it. I think we don't have time. If you want to think about this, how would you do this question, and then do it after. Remember how you are going to have a modulus question. I think you haven't, neither AQA or Edexcel have modulus question, no? Remember, we are just drawing the line, normal line, but then we are mirroring anything that is below the x-axis, yeah? And if I have to solve an inequality, it's interesting that you represent it first, even if they don't tell you, because you have to know, well, where are you, yeah? So the right one, so if you give me 1 minute, we can at least think about it. This one, the vertex is positive, so it's somewhere here, and the gradient is 5, so it's kind of very pointy, yeah? So it's something like this. This is number 1. Then the other one is the gradient is going to be 3, so it's going to be a bit more open, and the vertex is going to be on the left. So you have something like this and more open, yeah? Because the gradient is less. This one is gradient 5, this one is gradient 3. And they're asking you, sketching the graphs and decide, solve this inequality, yeah? So when this one, number 1, is greater or equal than number 2. So this is number 2. When is greater or equal? When it's above, yeah? So the black one is above here and here. So what you're going to do is to find the points of intersection. So this point of intersection, this point of intersection, and then say when x is greater than this, when x is smaller than that. how are we going to manage to find these points of intersection? Remember, the equation of this branch is the actual line positive. So it's going to be the 5x minus 3k, yeah? And so this is this branch. This branch is the same but negative. So it's well, a minus at the front if you want. 5x minus 3k, yeah? And this branch is the positive version of this one. So I'm doing the intersection of this one with y equals 3x plus 12k. So this one and this one and this one and this one. So when you are doing modulus functions, you have to consider that each branch, yeah, of the v really have different equations. Yeah, if you only use the positive, you will be doing the normal line. So this equation is the positive version. So this one will be y equals 5x minus 3k. This one is the one with the signs change. So minus 5x plus 3k. Yeah. So if you do a graph, you will see well which points are intersecting and where. Yeah. So these two branches are not going to intersect because this is more open than this one. So this is, I know in my drawing doesn't look like, but this is more vertical than this one, so they won't meet. That's why they tell you do a sketch, because if not, you don't know. You have like 4 possible combinations to find intersections, so it's more confusing. Yeah. Again, please check the masterclass that is on Google, on my website, because we are doing modulus functions and all that. Okay, do you have any question? No? And if you want to book the next Saturday class, that will be the last one. Again, the link is on my website, but I can send it later on when I send the recording. Yeah? Any question? No? Okay, good luck next week. If I don't see you earlier, and see some of you in a bit. Bye-bye.
Thank you.
Thanks, guys.